Okay, note 6.1 is accumulation of change. So when we are talking about that, what we're talking about is the area under a curve. So it says the region between a function and the x-axis is called the area under the curve. Under in this instance does not mean below. It means between the x-axis and the function. I would highlight that. Between the x-axis and the function. So if the function is above the x-axis, then we know we have a positive area. If the function is below the x-axis, then we have a negative area. So on this first one, I'm going to go ahead and you can either use your pencil or a highlighter. Color in the space between the function and the x-axis. And since the function was on top, we would say that this area is positive. Okay, and then on the next graph, we have the x-axis here, and then the function below it. Shade everything in between, and this would be correct, negative. Okay. They could also have a function that goes through the x-axis, which means we have positive and negative portions of the area. So we have this one space here, the middle, and then the end. Remember, you're always looking at the space between the x-axis and the function. So all the way on the left, is that positive or negative area? Negative. What about in the middle? Positive. And that at the other end? Negative. Okay. So it says the area under the curve gives us the accumulation of change. So this is the area under the curve. Any questions so far? Told you, real easy. We're just going to ease ourselves back into calculus. Okay, first example says you're on a road trip and you have your car on cruise control for 4 hours. You travel at 60 miles per hour. How far have you traveled? So cruise control means you don't change speed for the entire 4 hours. That is why we have a function that is a constant, a straight line. It says that we're in cruise control for 4 hours. So I'm going to take where 4 is and draw a line. I am still shading between the x-axis and my function. But in this case, I don't have a curve. I instead have what? A rectangle, right? A rectangle. And we are able to easily find the area of a rectangle by using what formula? Or we could say base times height. Correct? Does that mean the same thing? Length times width, base times height. Okay, so if we did this, what would be the base? 4 what? 4 hours. So we would say the area is equal to 4 hours. And what would be the height? 60 miles per hour. Okay. We would multiply these two numbers together, and 4 times 60 is 240. And what would be the units? Miles, because the hour cancels out. Okay, we were able to do this fairly easily because we know the area of a rectangle. Okay, if we were to translate this into integration, we would use an integral. So an integral is like a stretched out S. Okay, where we have start and stop points. So since we're talking about someone driving a car, okay, we're going to talk about the start and stop points for the hours that we are driving in this car. So the start would be 0, because at 0 hours we start our trip. And the stop is what it's asking for. So we're on cruise control for 4 hours, so 4. So this is the integral from 0 to 4. Okay. Then the next part that we place in here is our height. So the height in this case of our rectangle is what? 60. Good, in this case, I'm not going to put the units inside the integral. So 60, this is, again, my height. And then when we are looking at our area formula, we said it was height times base, or base times height. So what we use to determine base is just dt. Okay. So if I was to take the integral of this, ultimately it becomes 60 times 4. Okay, it doesn't make too much sense when it's an easy problem like this. Trust me, we'll get into harder problems. But it's just to show you that when we're dealing with integration, we are finding the area. Any questions so far? Okay, let's see if you guys can answer this, because maybe it was too early in the morning for first period. So it says the dependent unit multiply the independent unit. In other words, the unit for blank times the unit for blank.
Y, X.
Perfect. Y and X. Y is dependent, X is independent. So it's meaning we would look at the units on the y-axis versus the units on the x-axis. Example 2 says the graph below represents the rate at which water is leaking out of a tank. So I would highlight that rate that it's leaking out of a tank. The units are given in the graph. How much water has leaked out of the tank after 9 minutes? So anytime you see the word after, this was confusing for some earlier. It's not saying go to the graph, find 9, and look everything after. It's not saying that. It's saying that if you were to start at the beginning, and in this case we're talking about minutes on this x-axis, what would be the beginning minute? 0. It's saying if you were to start at the beginning and go to 9. So in this case, it's talking about the entire area under this function. Okay, so again, after, just think before. Okay, because a lot of people were actually looking at the graph after a certain point. So for this type of function, this is not a clear function that we know the area of. Instead, we could take this graph and divide it up into different shapes. Okay. Any ideas of what shapes we could divide this into?
Semicircle.
Semicircle, that's good. And triangle. And what's that other shape? Rectangle. Okay, so I can take it and divide it into 3 shapes. I'm going to go ahead and just label it 1, 2, and 3. So when I'm talking about the area of each, you'll be able to correlate them. So looking at 1, the semicircle, what is the area for a semicircle? Good, 1/2 pi r squared, because pi r squared is the area of an entire circle. If we want half of it, we just multiply it by 1/2. So if we were to solve this, what would be the radius of that semicircle? 2. So this is 1/2 pi times 2 squared. Okay, 2 squared is 4. Half of 4 is 2. So the area of that semicircle is 2 pi. Okay, now let's talk about the area of the rectangle. So we said above that that's base times height. What is the base in this case? 6. And what is the height? 2. So what's 6 times 2? 12. Okay, and then the last one is the area of that right triangle. What's the area of a triangle? 1/2 base times height. So we have 1/2 times, what's the base? 3. And what's the height? 2. So we have 1/2 times 6, which is 3. Okay. So in order to find the total area, what would we do with each of these individual areas? Add them together. So the area total would be equal to area 1 plus 2 plus 3. So all the individual areas, which is 2 pi plus 12 plus 3, which is 15 plus 2 pi. And what would the units be? Gallons. Because this is minutes times gallons per minute. The minutes cancel. We're just left with gallons. Okay. If we were to take this and use integration, this is how it would look like. So let's say that this entire function here, we're going to call that g of t. That entire function is g of t. Okay. We would need to find the area between what two values? 0 are starting and 9 are stopping, so from 0 to 9. Then we write our function, in this case it's g of t, and then we would write dt. You always are going to end it with dt, dx, dy, whatever that variable is. Okay, so if we were, once we learn the properties of integrals, right, we would be able to solve this if they gave us the equation for g of t. But since we weren't given the equation, we had to go back and use some of our algebra geometry skills to find the individual areas and add them together. So if we were to solve this, we would also get that same thing, 15 plus 2 pi gallons. Any questions so far? Okay, we have our last example. So in example 3, it says a particle is moving along the x-axis at a rate modeled by r of t, shown in the graph below. Before we look at A and B, those two questions, what we're going to do first is we are going to highlight all those areas. Okay, so I have one here, one down here, and then one up here. So it looks like those two triangle shapes on either end are a positive area, and then the trapezoid shape on the bottom is a negative area. So just based off of the image itself, would you say that this total area is going to be positive or negative? Negative. How did you come to that conclusion? There's more negative than positive when we're talking about those shaded regions. So again, before we answer these questions, we need to calculate what these individual areas are. So let's first start with the triangle. Okay, we know area of a triangle is 1/2 base times height. Okay, in this case, what is the base? 2. So this is 1/2 times 2. And what's the height? Everyone agree? 10? Yes, 10. Okay, don't want to confuse anyone here because some people may think, well, we only went up 2 spaces. But since the units are going by 5s, instead of going up 2, we actually went up 10. So multiplying that together, we get 10. So this area right here is 10. And if you check the triangle on the other side, does the base and the height match up with the first triangle? Yes. So that means that second triangle also has an area of 10. Okay, so this was the area for both those triangles. Okay, now we have to find the area of a trapezoid. Does anyone remember that formula? Yes, that is correct. So it's 1/2 height times base 1 plus base 2. Okay. So plugging in our information, we have 1/2. What would be the height in this case? Good, negative 15. It goes down to the negative 15 here. So we would include that negative 15. So remember, our area is supposed to be negative. So it makes sense to have that negative 15 in there. Okay, then what about the first base? What's the distance? Okay, 6. What about the second base? 2. So we have the top one with 6. The bottom one is 2. When we combine all of this, we get negative 60. So this one right here is negative 60. Okay, now we can go to our questions. So part A says, how far is the particle from its starting position after 10 seconds? So that means we're looking at which starting value first? 0 to 10. 0 to 10. Does that encompass the entire graph?
Yes.
So what are we going to do with each of those areas? Add them together. So we have 10 minus 60 plus 10, which gives us negative 40. Once we get an answer here, we have to write a statement. Okay. So it's asking us how far is the particle from its starting position. Well, we would say that the particle is 40 units to the left of starting position. In that case, that starting position is t equals 0. So notice in my statement, I did not put the negative value in it because here we are talking about the distance or the displacement from the starting to the end. So from 0 seconds to 10 seconds. Part B says, how far is the particle from its position at t equals 2 after t equals 8? So looking at our graph, does that mean we're going to start at 0? No, we're going to start at 2. So it's asking from 2 and stopping at 8. Which area is that?
The negative 60.
Only that negative 60. Okay, so I would say, okay, this would be the area of negative 60. I would write my statement, and this would say that the particle is 60 units to the left of starting position t equals 2 to t equals 8, because it was only asking for in between those two values. It wasn't telling us to start at 2 and stop at 10.